This week, parts of the central and eastern United States may feel like 105 to 115 degrees, even where many thermometers only show the 90s. But the problem is that this heat is not leaving cleanly after sunset, and the atmosphere above it is holding the pattern in place. By Thursday and Friday, July 2 and July 3, that locked pattern is forecast to push dangerous heat stress out of the Midwest and the Mississippi Valley. It will reach toward the Ohio Valley, the East Coast, the Southeast, and parts of the Northeast, while forecasters watch whether relief arrives fast enough. The useful signal is not the afternoon high alone. It is how the persistent heat dome traps heat and how humidity turns that heat into body stress. It is also whether the next forecast cycle shows the dome releasing the pressure or carrying it into July 7 through July 13. The system doing this is the persistent heat dome. Think of it as a lid that will not lift. The danger may be quietest after sunset, when the body and the building are supposed to recover. At the beginning of a heat wave, the afternoon high gets most of the attention. 95 degrees sounds familiar. 97 sounds uncomfortable, but not unusual. Then humidity is added, and the same air becomes something different to the human body. The Weather Prediction Center says heat index values may approach or exceed 105 to 110 degrees in many places. The broader Weather Prediction Center and Climate Prediction Center message allows for local values as high as 115 degrees. That number is not a headline trick. It is temperature and humidity translated into what the body has to fight. When the air is wet, sweat does not evaporate well. When sweat does not evaporate, the body loses one of its main cooling systems. So the first signal is not only how high the thermometer goes, it is how long the persistent heat dome keeps the body from dumping heat. Look at the map next, because this is not a single city heat alert. It is a regional dome being translated into local warnings. The Weather Prediction Center used unusually direct language in its extended forecast discussion. A significant, dangerous, and record-breaking heat wave is expected for the central to eastern United States. The peak is forecast around Thursday or Friday, with highs widely in the 90s to low 100s. That wording matters because it connects the heat to the system above it. A strong ridge is forecast to stay anchored over the eastern half of the country through the end of the week. That ridge is the persistent heat dome. It is the same feature behind alerts spreading from the central United States into the Mississippi Valley, the Ohio Valley, the Appalachians, the Mid-Atlantic, the Southeast, and parts of the Northeast. The footprint is the warning. Across the Midwest and upper Mississippi Valley, official products show heat index values around 105 degrees in the Chicago area. They climb up to 110 degrees in parts of Iowa, Minnesota, Wisconsin, Missouri, and Illinois. Farther south, the warning area around southern Illinois, southwest Indiana, western Kentucky, and southeast Missouri has values up to 113 degrees. Middle Tennessee has its own warning signal, with heat index values up to 112 degrees west of the Cumberland Plateau. Around Kentucky and southern Indiana, the Louisville forecast area is looking at afternoon and evening heat index values from 100 to 115 degrees. Now move east. Parts of Pennsylvania, New Jersey, Delaware, New York, and New England have watches and advisories tied to midweek heat, with some watch areas allowing heat index values up to 110 degrees. The Mid-Atlantic signal is especially important, because some of those same areas may hold overnight lows in the mid-70s to low 80s. That changes the meaning of the event. At first, the persistent heat dome looks like a daytime temperature problem. Once the overnight lows are added, it becomes a recovery problem. A normal hot day gives some relief after dark, pavement cools. Buildings release heat, the body gets a break. Air conditioners do not have to fight the same load all night. When lows stay in the 70s to around 80 degrees, the next day begins from a warmer starting point. The heat carries over. That is why major to extreme heat risk matters in this setup. The category is not only saying the afternoon feels bad. It is saying heat may affect anyone without effective cooling or hydration, and some places may face long-duration heat with little overnight relief. The official alerts are local. The object connecting them is regional. The persistent heat dome is the same system behind the Midwest warnings, the Ohio Valley Heat Index values, the East Coast watches, and the warm night signal. The next question is physical. What is this dome actually doing? Start above the surface. A mid-level and upper-level ridge is a bulge of high pressure in the atmosphere. Beneath that ridge, air sinks. As it sinks, it compresses and warms. It also makes widespread clouds and storms harder to form because storms need rising air. The local version was described by NWS Louisville as an anomalous upper ridge with a strong subsidence inversion. Put plainly, air near the ground wants to rise and mix out. The layer above it pushes back down. The surface heats, humidity pools near the ground, and broad cooling is suppressed. The persistent heat dome is not just sitting over the region. It is limiting relief. Now add the moisture. Heat index or apparent temperature is not a fake number, and it is not just a feeling. It measures how heat and humidity combine inside the body's cooling problem. Sweat cools you only when it evaporates. High humidity slows that evaporation, so the same 95-degree air can hit the body like 105, 110, or higher. The National Weather Service places heat index values from 103 to 124 degrees in the danger range. At that level, heat cramps or heat exhaustion become likely with prolonged exposure or activity, and heat stroke becomes possible. One health number changes the tone. CDC and NIOSH guidance says heat stroke can raise body temperature to 106 degrees or higher within 10 to 15 minutes. Without emergency treatment, it can cause death or permanent disability. A forecast heat index of 105 to 115 degrees is not describing comfort. It is describing a physiological threshold. Warm nights make that threshold more dangerous because recovery is part of survival. A person can handle heat more safely when the body cools at night. A building becomes safer when indoor temperatures fall before morning. Under the persistent heat dome, the overnight period may not reset the system. A bedroom, an apartment, a workplace, and a street can all begin the next day still carrying heat from the day before. The night is the compounding layer. There is also a false relief built into this forecast. Storms, clouds, or rain can lower actual air temperatures. In some places, that would help. A well-timed storm complex could undercut the heat and bring real relief. The Louisville forecast discussion points out the complication. Recent rainfall can lower the actual temperature while raising dew points. A dew point is a measure of how much moisture is in the air. Higher dew points make sweat evaporate less efficiently. So the thermometer may drop, while the heat index does not fall very much. Forecasters called that a wash. Picture a storm cooling the pavement but leaving the air thick and wet. The afternoon high comes down a few degrees, but the body still cannot cool properly. The visible weather changed. The human heat risk stayed in place. Set that next to the larger pattern, because it shows the hidden strength of the persistent heat dome. It does not have to push every location past 100 degrees to be dangerous. It only has to keep heat, humidity, and warm nights connected long enough for the body to lose its chance to recover. The ground impact comes into focus now, because the worst heat disasters do not look like the storms people are trained to fear. There is no funnel on the horizon, no water rushing down a street. No roof lifting away on camera, the most dangerous place can be a closed room after several hot nights. Chicago proved that in July of 1995. During that humid Midwest heat disaster, the heat index peaked at 119 degrees on July 13. Between July 11 and July 27, 465 heat-related deaths were certified in Chicago. The median age of the people who died was 75. The detail that matters most is not only the death toll. CDC documentation included people found in enclosed rooms without air conditioning, with windows closed and high ambient temperature. That is the mechanism made visible. The heat did not need to knock anything down. It entered rooms, stayed there, and outlasted the body's ability to cool. Stay with that for a second, because it explains why the current warm night signal matters so much. If lows stay in the mid-70s to low 80s, homes and apartments may not shed heat before the next afternoon begins. For older adults, people with chronic conditions, outdoor workers, people without reliable air conditioning, and people on certain medications, the risk can grow hour by hour. Heat is quiet until it is not. The same dome also shows up in infrastructure. PJM Interconnection, the grid operator for a large part of the eastern United States, issued hot weather alerts for June 29 through July 3. Its forecast peak load rises to 160,892 megawatts on July 2. The summer record is 165,563 megawatts, set in 2006. A hot weather alert is not a blackout forecast. PJM's alert is a preparedness signal, not a failure prediction. It shows the scale of cooling demand. Buildings are trying to shed trapped heat at the same time. Air conditioners are running longer. Warm nights keep demand elevated because structures do not cool down cleanly after sunset. The grid becomes another thermometer for the persistent heat dome. The apparent good news is that the forecast allows for heat to ease west to east this weekend, as the ridge weakens and a shortwave approaches the Great Lakes and Midwest. That could matter. A stronger break, lower dew points, and cooler nights would reduce the risk. But the timing is not locked. The Weather Prediction Center has higher confidence in the ridge through late week, and lower confidence in the exact timing of the breakdown. The Climate Prediction Center also keeps a slight risk of extreme heat in parts of the eastern United States on July 7 and July 8. Additional risk signals extend farther west and central after that. The weekend front is not a finish line yet. It is part of the test. There is one more thing to address before the closing signal. When a weather pattern becomes this large and uncomfortable, another story often spreads beside the real one. The claim is that heat domes or record heat are being artificially engineered by weather control technology. It is reasonable to ask what is driving a pattern this persistent. The artificial control claim does not match the physics or the official evidence. Weather Prediction Center and National Weather Service products explain this event through a large-scale ridge, sinking air, high humidity, warm nights, and the forecast evolution of the atmosphere. Nothing in the official record supports the idea that a human transmitter can create or steer a multi-state ridge like this one, shape a regional humidity field, generate daily heat records, or drive grid-scale demand the way this pattern has. The legitimate question is why persistent ridges, high dew points, and warm nights are producing more dangerous heat risk events, and how confidently forecasters can time the breakdown. Now separate the measured risk from the exaggerations. Every city is not forecast to reach 115 degrees. A PJM hot weather alert is not an outage forecast. A weekend front is not guaranteed to fail everywhere. The measured story is narrower and more useful. This is a heat risk event with a specific test. The persistent heat dome is dangerous as long as it keeps apparent temperatures high and prevents recovery. The most important thermometer may be inside a closed room after midnight. The products to watch are the ones that measure whether the room, the street, and the body finally get relief. The Weather Prediction Center Extended Forecast discussion updates twice daily and shows whether the ridge is breaking. The WPC Maximum Heat Index forecast shows what the body may experience. Local National Weather Service watches, warnings, and advisories show county-level risk. The Climate Prediction Center Week 2 Hazards and Heat Index Outlook, issued daily in the afternoon, shows whether the signal survives into July 7 through July 13. PJM hot weather operations matter if load projections climb toward the summer record or emergency procedures begin. The test is one pairing. Shrinking 105-degree-plus heat index fields with cooler nights mean the persistent heat dome is releasing. Persistent 105 to 110-degree fields with upper 70s or low 80s nights mean it is still working, especially if the Climate Prediction Center keeps July 7 through July 13 heat risk alive. Do not judge this by the afternoon high alone. Watch the apparent temperature, then watch the nighttime low. That is where this dome either starts to release or carries the heat into the next forecast window.